All right. So we have learned how to declare variable of different types, right? So if we have whole numbers, we can use int, short, long int, right? Or we can use unsigned short, unsigned int, and unsigned long, right? If we have floating point numbers, we can use double or float or long double. If we have character type, we can use char basically, right? So we have data, right? And then we basically perform operations on data, right? So there are different types of operators, right? So some of them, they work on two different data. Some of them work on basically single data, right? So they are, they may be binary operators or they may be unary operators, right? So here, let's see the different types of operators, right? And how they basically how they use basically the numbers or data when they basically perform the operation, right? So let's start with basically unary operator, right? So from the name, it is clear that they will only take one data basically for their operation, right? So the example of unary operators are basically this negate operator, right? So this basically flips the non-zero value to zero and zero value to non-zero, right? Okay. So that's called basically uh, negate operator, right? So here, for example, if I put, let's say, this exclamation before, let's say, a non-zero number, let's say 5, right? So then I will get basically 0, right? But if I'll put basically this exclamation operator before is zero value, so I will get 1 basically, okay? So here, this is the example of basically negate operator. It will take only one data, right? So here, one number here, right? So that's example of this negate operator, right? And the associativity of this operator is right to left, right? So first it will check the right data type, and then it will apply this operator, right? Okay. Similarly, here it will first check this number, and then it will apply this operator, right? So right to left. Similarly, you have a minus operator, right? So if you have minus operator before basically any number, so that number will be multiplied with -1 basically, right? So if I write -5, which means that you are multiplying 1 and then you are getting -5, right? So you can easily see that this is basically -5, right? So this is called basically uh, uh, minus operator, right? Then we have basically this plus plus operator, which is used to increment some number by 1 basically, right? So if I write, let's say, and we apply it basically with variable, let's say if I have variable I, right, and I is 1, right? And then if I basically do write like this, I plus plus, right? Okay. So it will become basically, I will become basically like this, I plus 1. And since I is 1, 1 plus 1, I will become now 2 basically, right? Okay. And then we have similarly, we have minus minus operator, which is called decrement operator. It will decrement the value of a variable by 1, right? So that's unary operator, right? Then we have arithmetic operator, right? So arithmetic operator, uh, arithmetic operators, they are binary operators. They will take two data and then they will apply basically the operator into that, right? So here, the example of arithmetic operators are multiplication, division, and then remainder operator. I will talk about that in a few minutes, right? Then we have plus, and then we have minus, right? So the example of arithmetic operators, how they are used, let's say I have two number. If I do 5 times 3, right? So here I will scan from left to right. So the associativity is left to right, right? And then 5 will be multiplied with basically 3, right? And then I will have basically 15, right? Similarly, if I have 17 minus 12, right? So then I will scan the numbers from left to right, and then I will apply the operator into it. Then I will get basically 5, right? So these are some arithmetic operators, right? So here, this operator that you are seeing here, this is called remainder operator or modulus operator, right? So this operator is only applied with integers, right? So if both the operand or data, so we also call data as operand basically. If both the operands are integers, then you can use this operator, right? So if, and what is the meaning of this operator, right? So let's say if I write 15% 4, right? So what does it mean? That this operator will give you the value. And what is that value? The value is that when 15 is divided by 4, what is the remainder that you are getting, right? So if you divide 15 by 4, the remainder that we get is basically 3, right? So the outcome of this operation will be 3, right? Similarly, if I write basically 16% 5, right? So when I divide 16 by 5, I get 1 as a remainder, right? So then this is the outcome of this remainder operator, right? So the remainder operator gives you the remainder when the left side integer is divided by the right side integer, right? And keep in mind that this remainder operator is only applied when both the operands, both the data, if they're integers, okay? And you also see that the precedence of these operators, right? So here the precedence is shown from top to basically bottom, right? So those operators which are coming first, they have higher precedence than those operators which are coming at the bottom, right? So here, if you look at that, all the unary operators, they have highest precedence over any other operator. And even in arithmetic operator, this multiplication, division, and remainder operator, they have same precedence because they are coming in the same row, but they have higher precedence over the plus and minus operator, right? So for example, if I basically write this 5 plus 3 times 4, right? Okay. So now here you have two operators, right? One is plus, another is basically multiplication, right? So now since multiplication has higher precedence over plus operator, so first basically this part will be computed, right? So here now left to right, so this part will be computed. So right, 3 times 4 we have 12, right? And then we have this. Okay? Now you will add 12 with 5, then you will get 17, basically, right? So you should also when you write expression, right? So you should be careful with the operator precedence, right? Then we have relational operators, which are used to compare basically numbers or operands, right? And they basically return either 1 or 0. If the comparison is true, they will return 1. If the comparison is false, they will return 0, right? And they are used for basically decision making, which we'll cover later on, right? So there are many relational operator. One operator is called smaller, right? So if I write, let's say 5 is smaller than 6, right? So we are comparing basically 5 with 6 basically, and we are comparing for smaller than relation, right? So, and we know that 5 is smaller than 6, so then this will result basically 1, right? But if I write, let's say 4 is smaller than 3, right? So which is false, so this will return basically 0, right? So we have smaller than, we have greater than, and then we have also smaller than or equal to, right? So if I write basically, let's say 4 is smaller than or equal to 5, which is also true because 4 is smaller than 5, which is true, right? And if I write, let's say 4, which will yield true, if I write 4 is smaller than equal to 4, which is also true because 4 is equal to 4, at least that part is satisfied, so it will also return 1, right? But if I write 3 is smaller than or equal to 4, right? So then it is false because 3 is sorry. So if I write basically 3 greater than or equal to 4, which is false because 3 is not equal to 4 and 3 is not greater than 4, which is false, right? So you have these basically operators, right? And then you have also equal, equal, and not equal operator, right? So here you have two basically double equal symbols, which means that you are comparing two numbers for equality, right? So if I write basically, let's say 4 equal 5, so which means that I'm comparing 4 with 5 for checking that whether they are equal or not, right? So since 4 is not equal to 5, so this will yield 0, right? But if I write 5 equal 5, which is true, it will return basically 1, right? And instead of these constant, I can also use variables, right? So these variables may be integer or floating point, right? So I can also write, let's say a is a variable which is of type integer. Let's say I can also compare this a, some number, let's say 5, right? So if a is 5, then this will, let's say a is 5, int a is 5. Since a is 5, right? So this result will give you basically 1. But if I compare a with basically 4, this will give you 0, because a is 5, you're comparing with 4 for equality. They are not equal, 0, right? Similarly, you have not equal operator, which is basically used when two numbers are basically uh, to check that whether two numbers are not equal or not, right? So here, for example, let's say we have int a equal 5, and we are doing this, right? So now we're comparing a with 4 for not equality, which is true because a is 5, and you are comparing it with 4 for not equality, so it will give you basically a true result, right? So you have relational operator, right? Okay. And then you have logical operator, right? So these logical operator, basically, they are used to combine different expression, right? So you have logical operator and logical operator or. So and has higher precedence over or basically, right? So what is basically and does? So and is used to combine multiple relational expression or arithmetic expression, and then you basically join them, right? And same thing you do for or, right? So the example that you will see in programming, that let's say you have some situation, let's say where you want to test two conditions and both of them should be true, right? So then you use basically this operator, right? Okay. And then or operator you will use when you have two situations. If any one of them is basically true, then you will basically use this or operator, right? So you have and or. And then we have assignment operator. So we have single equal symbol, which is used to assign whatever you have on the right side in your computation, you will assign it to a left side basically variable, right? So that's called assignment operator, right? And then we have few other basically assignment operators that you will see later on in the slide, right? So these are different operators. Some of them are arithmetic operators, and some of them are relational, logical, and assignment operators, right? And here, their precedence basically go from top to bottom, right? So for example, if in an expression you have, let's say, um, together you have, let's say, multiplication, and you have, let's say, plus. So then first multiplication will be performed, then basically plus will be performed, right? So here, let's focus on arithmetic operations for integer, for basically numbers, basically, right? So there are some rules for evaluating arithmetic expression, right? So here, if both the operands or data uh, around the operator, if they are integers, then your result will be integer, right? So for example, if you have 5 plus 4, so this will give you basically an integer number 9, right? Inside the computer, right? So that this result will be stored as an integer inside the computer, right? But if you have one of the operand is a floating point number, then your result will be a floating point, right? So let's say if I have 5 plus 4.0, right? So this is 9.0, right? So now this 9.0 will be stored as a floating point number inside the computer, right? So if one of the operand is floating point, your result is basically floating point, right? Okay. So here, let's say you have like different combinations of the operands type, right? So let's say if both the operands are integer and you apply an operator, you will get basically an integer as a result, right? If one of the operand is basically double, you will get basically a double in the result, right? If one of the operand is basically is a float, right? So then you will get the result in the float. If one of the operand is double type and the another is float, then the result is double. Basically, the operand which has higher basically precision or which is a higher type, your result is promoted to that type. It is called implicit conversion. Okay. Right. So for example, if I have, let's say, 5, okay, plus 4.9, right? So by default, actually, a floating point number is double, right? So then the result will be basically 9.9, which is a double, and it will be stored has a double inside the computer, right? So keep that thing in mind. And also when you have operations on integer, so sometimes problems happen, right? So one of the problem is called like overflow problem, right? So overflow problem happens when you are, we know that like every subtype of integer has a range of values, right? So when you will run this program, size underscore values.cpp, right? So you will see the range of maximum and minimum values for each subtype, right? So every integer type has a range, right? And when you perform an operation on those basically integer type, if the result exceeds the range, then you will have overflow problem, right? So let's say, for example, uh, we have uh, let's say short integer. Let's say we have a short, and this short basically we have a variable for short type, right? Let's say num, right? And this short num, let's say, so by default we have just put short, so it is a signed num, right? So num is a variable of short, so it can have only value from negative 537 up to positive 16,538. Okay, so this is the range that it can hold, right? So it will hold basically negative 16,537 up to 16,538, right? Now, if I basically do this, I assign, let's say num is equal to 20,000. So now you see that this 20,000, it is basically exceeding the range, right? So then the overflow will happen with this num. So num will not store this 20,000, rather it will store something in between these values, so which is incorrect, right? So that's called overflow problem. Second thing is the division problem, right? So one problem that happens with division that if you are coming from basically non-programming background, and let's say you are doing this, let's say in programming you are doing this, 15 divided by 2, right? So from your math knowledge, you will think that this should give you basically 7.5, right? Okay. But if you recall the programming rule, right? So here you have, this is basically an integer, right? And this is another integer, right? And when you perform integer, when your both operands are integers, so your result should be also integer, right? So in this case, since both of them are integers, right? And you are performing division, right? So then your result should be also an integer. So in this case, your programming will basically output will not 7.5, rather it will be 7. It will not be 7.5 because this 0.5 will be truncated, right? So many times people think that, okay, whatever you are getting in the math for integer division, you should also get in the programming, which will give you basically incorrect value, right? So you will get this one, right? But to get like 7.5 for this operation, so what I will do basically, I will do 15 divided by 2.5, then I will definitely get 7.5 because one of the operand is floating point, right? And then also sometime uh, people basically they divide basically a number by 0. It says 15 divided by 0. So in basically in math, this should give you an infinity, but here you will get a basically problem, runtime problem, which is called divide by 0 problem. Okay, so you should be careful for that too, right? And then modulus operator, it is applied only with integers, right? And then the result you will get is the remainder, keep in mind. So here you have divided 15 by 2. So it will basically give you the remainder, which is basically 1, right? So you can like work on these examples and you can see what output you are getting, okay? So now let's talk about basically expressions, right? So expressions basically, they are a combination of operands, basically data. The data could be constant and variables, and the operators, right? Which can be evaluated, right? So here, for example, an expression could be, let's say 5.4, right? So this is an expression, arithmetic expression where you are adding 5 and 4, right? So example of arithmetic expressions are, let's say 3 plus 7, 0.5 times 14.6, on plus 1, 2 times 3.14 times radius, right? So here, these are basically valid expressions, right? Then you may have relational expressions, and relations expression like 30 greater than 40, which you are comparing 30 with 40, right? And then relational expression, they will basically generate either 0 or 1 if the comparison is true or false, right? So here you are saying the 30 greater than 40, which is false because 30 is smaller than 40. So this will give you basically 0 value, right? And here, let's say length is a variable which will have some value. If this length is smaller than or equal to 50, then you will get true. Otherwise, you will get 0. And similarly here, we're comparing value with 10 for not equality. So if value has a value which is equal to 10, then this will give you basically 0 output because 10, you're comparing 10 with 10 for not equality, which is false, right? But if, let's say, value has a value, let's say 20, and you're comparing it with 10 for not equally, so 20 is not equal to 10, then it will give you basically 1 output, right? Similarly, you can check that for this example. Logical expression, right? So they use logical operators around the expressions, right? So logical operator is AND, which is 2 ampersand symbol, and then logical OR, which is 2 vertical bars, right? So here, this basically AND operator, it will give you 1 when both the operands are non-zero, right? So here in otherwise, it will give you 0. So here you see the left operand is 10, and the right operand is basically 0. So this one is basically 0. So if one of any of the operand is 0, then your result will be 0, right? Okay. So here let's look at this example. So here you have basically this 0. It has the negate operator, right? So and then you have this logical AND operator. So if you look at the operator precedence, right? So this negate operator has higher precedence over this logical AND operator. So first, this part will be executed, right? This part will be evaluated, right? So you apply negate operator on a 0 number, right? So it will give you a non-zero value, right? So negate 0 will give you basically negate 0 will give you 1, right? And then you are doing one logical ANDing with 1, right? So 1 and 1. So it will basically give you 1 because both the operands are non-zero. So 1, right? And then here you can basically see that for logical OR, if any of the operand is non-zero, then it will give you 1 basically. So here, if you see 0 logical OR with 1, so this is non-zero, so you'll get 1, right? So relational expressions are used to compare operands, right? And logical expressions are used to create complex conditions, right? So they produce either 1 or 0, and they are used in basically branching and looping, which we'll talk later on in the class, right? In logical expression, you keep in mind any non-zero operand is considered as 1 true, basically, okay? So here are some examples of basically logical expression, right? So here, let's say one example is that you have a variable score, and then you have this logical condition: score greater than 70 and score less than or equal to 80. So if you have a score variable, basically, let's say 75. So 75 is greater than 70, which is true, right? And then 75 is smaller than or equal to 80, which is also true. Then this output will give you basically 1. Right? But let's say score is 90. So 90 is greater than 70, which is true, so it will be 1. But 90 is not smaller or equal to 80, which is false. So 1 and false will give you 0, right? So same thing you can apply for other examples. Right. So now how in programming the expressions are evaluated, right? So let's say you have this basically example here, right? So let's say your program has to evaluate this expression, right? So it's a long expression, and so your program will follow the operator precedence and what they do basically, right? So here, so your program will scan this expression from left to right, right? So if you have something inside parentheses, so that will get the highest precedence, right? So here you see that we have this whole expression, right, inside the parentheses. So first it will be evaluated, right? So now let's look at this, what we have inside the parentheses, right? So we have now 6 times 3 equal 36 divided by 2, right? So here we have 3 operators, this one and this one and this one, right? So here, if you look at this, right? So we have this multiplication and division, they have same precedence, but their precedence is greater than basically equal, right? So first they will be evaluated, then you will evaluate it with this equal, right? So since like this multiplication operator comes first, then before basically this division operator, so first this will be evaluated, right? So 6 times 3 will be calculated. You will have 18, and then you will have basically equal 36 by 2, right? So now you have 18, and then you have basically this operator, and then this operator, right? Okay. So this operator will have higher precedence than this equal operator. So you will have basically this computation, right? So now you have 18 and 18, and then 18 and 18, they're compared for equality, right? So since they are equal, so this will give you basically 1, right? So now you will have 1. And then now the second thing that you have to evaluate is that whatever you have inside this parenthesis, right? So you will go on in this way and you will find that. Okay? So you will get basically at the end, you will get that 1 logical OR with 0. And we know that if you have if any of the operand in OR operation is non-zero, right? So here you have one operand which is non-zero. So your outcome will be basically 1, right? So that's how basically expressions are evaluated, right? Now let's look at basically the assignment operator, right? So here, assignment operator, you will see that you will see them many times in your programming, and you already have seen in the class example that we discussed, right? So here, let's say we write some expression. Let's say sum is equal to 3 plus 7, right? So how this expression will be evaluated, right? So here, first what will happen, this 3 plus 7 will be evaluated. The expression which comes on the right of the equal symbol, right? So that will be basically evaluated. So 3 plus 7 is 10. And then that value will be assigned to sum. So sum will become basically 10. Okay? Similarly, here in this example, first 0.05 will be multiplied with 14.6 on the right side, and then that will be assigned to product, right? Okay. So here, in assignment expression, you may have basically a lot of operands and operators on the right side. So you see that here you have 2 operands, 1 operator, 2 operands, 1 operator. Here you have 3 operands. 2 of them are variable. One is basically constant. And here you have all of them are basically variables, right? So on the right side, you may have 1 or more basically operands and operators. But on the left side, you should have only one operand, right? So here you see that you have only one operand, one operand, one operand. Right? So if you are writing like something like this in your programming, it will give you an error, basically. Okay, right? So this is not allowed, right? And also keep in mind that this single equal and this double equal, they are different. So they are basically different. They are not same basically, right? So you know that this single equal sign is used for assignment, right? So here it is used for assignment, right? And this is used for basically equality comparison, whether two numbers are equal or not. Keep in mind, okay? So now let's we have this assignment operators discussion. Let's work on an example where basically you will use all the knowledge that we have gained so far, and you will write a program that will basically compute the area of a circle, right? So you know that area of a circle is basically pi times r square, right? So here pi basically is a double number because it has value 14, right? And so on, right? And then so if you multiply anything with this number, right? So you will get basically a double value, right? So the area of, so how you will determine the data type, right? So let's say you have variables, one for area, one for radius, and one for basically pi, right? So area will definitely be a floating point. Pi is also a floating point, right? So you have to declare them as basically floating point type. So either you can declare them double, float. So let's go with double, which is very common, right? And radius, you can also treat it as basically double because the user can give radius 3.5, 4.5, 3, and so on, right? So let's write a program for that, right? So here you can try this basically. Here we have basically this program. You should try this in your computer and see how does it work, right?